Hi all, welcome back to my session of electromagnetic field theory. Myself Dr. Sayanti Chatterjee, Associate Professor of Department of Electrical and Electronics Engineering of Institute of Aeronautical Engineering College, Hyderabad. Today I am going to tell about the topic electrostatics, and this is a problem solving session. Already we have completed one problem solving session on the same topic. Today we are going to do the another topic of the electrostatics. So what is the course outcome? Course outcome of the electrostatics is students will be able to apply or make use of Gauss law for obtaining the electric field intensity, density of uniform and non-uniform regions. So these are the main use of this today's session. So we will do a small revision before starting that topic. First one, Coulombs Law. What is Coulombs Law? Coulombs Law is the force between two charges depends on Q1, Q2 by 4 pi epsilon R12 squared AR. What is AR cap? AR cap is the direction or unit vector along the radius or distance between two charges. These charges may be like charges, these charges may be unlike charges. Then we will go for the electric field intensity. The electric field intensity E can be defined as the Q1 by 4 pi epsilon R12 square. So this is the equation of the electric field intensity. So what is the relation between the Coulombs law and electric field intensity? If we compare these two equations, the equation is E is equal to F by Q. You can see if we divide the F12 divided by Q2, we can get the Q1. Coulombs law is the force between two charges have some distance R12. And what is field intensity? The force required to bring one unit positive charge to a electric field. So this is for here Q2, or the second charge is the 1 coulomb. Next we will discuss the next equation, that is the Gauss law, which is the more important equation. What is Gauss law? The flux passing through any closed surface is equal to the total charge enclosed by the surface. What does it mean? If when there is a charge, we know there is some electric flux, and electric flux is basically imaginary. So electric flux passing through any closed surface is equals to the total charge enclosed by the surface, and the surface may be uniform or may be non-uniform. So psi is equal to, this symbol means this is a closed path, d dot ds equals to q. So if this is a closed path, and you can see these are the number of charges q, so the number of lines of flux psi is equals to q, and it depends on the flux density ds and the surface area, the direction of the surface area. Next we will discuss the work done in a moving point charge. So what is the work done? Work done when we can move one charge q by a distance dl meter, what will happen? Let's start. If a point charge q is kept in an electric field, so this is an electric field, and this we can keep one charge q for the electric field, it will experience a force. And what is the force? The force will be the direction opposite to F. What is F? The field strength. So we can write, if you can see this is an electric field, you can see this is the electric lines of force due to the charge q. due to the charge Q, you can see there are the positive charge, these are the negative charge, and there are n number of electric lines of force. So if we put a charge Q on it, it will feel some force. It will feel some force. If F is the direction of the field strength, if F is the direction of the field strength, Fa, the force on the charge, will be in the opposite side. You can see that it is in the opposite side. So that's why it is told Q is kept in an electric field if A is applied force in the direction opposite that of F. Now, if we are moving the charge in this field, when we are moving the charge, there will be some work done. And if we move the charge in the L direction, so what will happen if the direction is dl and we are moving it from A to B? We are moving the charge from A to B. What will happen? We can calculate the work done. Now, we know that the work done is equal to, we know the work done dW can be written as the force and dot dl. What is dl? dl is nothing but the distance between A to B. You can see one thing here, we have written F with the arrow mark. This also means the vector, and dl is in the bold. Bold also means this is a vector quantity. And what is F? We know already, we have discussed in the previous slide that F equals to Q into E. We got the relation F, the total force, is for Q into E. What is E? E is nothing but the field intensity. So what will be the W? W is integration of F dot dl. Now we are substituting the F with Q into E dl. So you can see this is the force and this is the opposite force. We are moving it from A to B. We are moving it in the A to B direction. So already W is equal to integration of dW. So what is W? So we are moving it from A to B. Integration of A to B is equal to QE dl. So this is the work done when for a moving charge. So when we are moving a charge, we can tell W is equal to A to B QE dl. And what is the direction of the work done? It is always in the direct opposite to the force. So let's do a small problem from this topic. Find the work done in a moving coil or moving charge of minus 20 microcoulomb from origin to 400 in the field E is equal to x by 2 plus 2yi plus 2xj. So what is this? So we can think I vector and j vector. Okay, we will write it in a 3-dimensional. This is x, this is y, and this is z. So what is the step 1? So determine the starting point and end point. So what is the starting point and end point? So this is our x, y, z. What is the meaning of starting point? Starting point is from origin. We can see this is from origin. So what is the point? From origin to the point 400. 400 means it is in the x-axis. 0, 0, 0 to the another point. And what is the point? 4, 0, 0. So we can write the starting point is origin and end point is 400. What is to solve the integration? solve the integration over the point. So what is our formula for integration? Already we have discussed. W is equal to integration of Q E B dl. So what is the value of Q? Q value is given as 20 microcoulomb. So we can write Q is equal to, it is given as 20 microcoulomb. Microcoulomb means 10 to the power minus 6 coulomb. Then what is the value of E? E value is given as x by 2 to y. What does it I means? In my old lecture in YouTube video, you can find that I is similar to the ax, the vector with respect to the x axis. And what is j? J is similar to the ay. These both are actually similar. So we can write what is the value? Integration of a to b, x by 2 plus 2y plus, this is our E, and what is our dl? First we have to calculate the starting point and end point. So it is the equation. It is I, we can write I plus 2xj. This is the, what is this? This is the equation. We can write it as the dl. So this will be with respect to x and this will be with respect to y. What is the integration range? Integration range is from origin to 400. So we can write, what is dl? dl we can write as dx into I plus dy into j. As in this equation, there is no z component, we are not writing the z component. So what will be the integration? If we multiply this to x by 2 plus 2y, this is the dot product. So I dot I is equal to 1. We are getting dx. And what is the range of x? From origin 0 to 4. And what is the next integration? 2x dy. 2x dy. And here is the q. I forgot to write q. This is the q. 2x dy. And what is the integration range of y? Y is origin to 0. So it is 0 to 0. So we can just skip this portion. We can skip this portion. So this is our equation. So if we want to calculate it, what is the value? It is coming x square by 4. X square by 4 plus 2xy. Now y value is 0. So we can also remove this because y value is 0. It is starting point is origin and in the point P there is no y value. So what is we are getting ultimately? Q is equal to x square by 2 0 to 4. So we are getting 16 by 2 means 8 0 to 4 and ultimately the value we are getting 80 into 10 to the power minus 6. We are getting the value 80 into 10 to the power minus 6 j. So this is the procedure to calculate the work done. First, we have to know the determinant of the starting point and end point. Second point is we have to do the integration. So next we are coming to the next point, electric potential. What is electric potential? Work done to move unit positive point charge through the existing electric field is known as the electric potential. Work done to move unit positive point charge through the existing electric field is known as the electric potential. So what is the work done we got? We got the work done is equal to integration of A to B. Integration of A to B QEdL. But we know that the what is electrical potential definition? Work done to move unit positive charge from one point to another point. So it is for the Q charge. So we can write V is equal to W total work done by Q. So what will be the equation? It will be Q E V is equal to, for one charge, it will be divided by total charge Q. So we are getting the value minus integration A to B E dot dl. And work done, the potential is always from the, if we are writing VAB, so it will be VA minus VB, the near point to the far point, to bring one unit charge from one point to another point. VAB is nothing but the VA minus VB. You can see the minus sign here also. So we are coming to our tutorial question bank, and this is a very important question. The electrical potential due to a disk. After that we will go to the problem, but we need to solve this one. How to calculate electrical potential due to the disk. So you can see this is a disk. This is a disk. What is the example of the disk? You can understand the disk is nothing but this type of something. This is the disk. This is the disk. It has some width. You can see this has some width. This is not the like a circle. And this width, the width of this disk, we are taking as the dx. Here we are taking as the dx to the width. Dx is nothing but the width of the disk. Now it has two radius. One is the internal radius, and internal radius is given as x, and one is the external radius. Now we are assuming a point at which, from where we are bringing the point to the center. From the point P, we are bringing the charge in the center, and the distance between the linear distance is h, and the distance between the disk to the point is, we are assuming this is r. And if this is x, the external is the x plus dx. So this is the thing. We are bringing one positive unit charge at the, from the P to the center, from P to the center. This linear length, radius is P, and we are taking the distance as r. So what is dV? We know what is the dV equation. dV is equal to nothing but the dq 4 pi epsilon r. What is r? R, this is for a sphere, or this is for a circular path. And what is r? R, you can see the point from the disk to the external point. Now, when we are thinking about a sphere, about a disk, we have to think, we have to know the general tendency of the charge is to lie on the outside of the surface. So we will take the surface charge density rho s. And what is dq and rho s relation? dq by ds is equal to rho s. We know the relation. dq is equal to rho s ds, where rho s is equal to surface charge density. Rho s is nothing but the surface charge density. So what is dB? Now this is a circle. So in the circle, what will, if we are taking a small area in this sector, if we are taking a small area in this sector, if we are taking a small area in this sector, What is its value? The total value is 2 pi x. It is 2 pi x, the perimeter of the circle, into dx. What is dx? Dx is nothing but the width of the disk. So what is dB? dB is equal to rho is 2 pi x dx. So what is dx? dx is the width of the disk. 2 pi x is the total. If x is the radius, then 2 pi x is the perimeter of the disk. Now this 2 pi cancel out and we got the simplified equation dB is equal to rho s x dx 2 pi r. Now what is r? From this is a right angle triangle. You can see this triangle is a right angle triangle. So what is x? What is r? R is nothing but the x square plus h square. This is nothing but the x square plus h square. So what is dB? dB is equal to rho is x dx 2 epsilon. In the place of r, we can write x square plus h square. Then what is b? What is b? b is we are bringing the charge from P, means this is our h distance, to this disk, from this point to this point. So h to root of a square plus h square. And this is the, after doing the integration, we will get for a disk, V is nothing but the rho s by 2 pi. So the potential for a disk depends on the rho s surface charge density by 2 pi epsilon. What is epsilon? Epsilon is the permittivity of the media into root of a square plus h square minus h. A square plus h square minus h. So this is the complete relation. This is the complete relation of the voltage. Now if we want to bring the point at the center means this distance is, why we are writing a? If x equals to a, we are assuming the x value as the a. So if we want to make it in the center, means a square is equal to 0. So the potential will be also, a will be h. So at the center, when h is equal to 0, at the center means there is no height. If we want to bring a charge from here to this point, h is equal to 0, v is equal to rho s by 2 pi into a. So this is the another relation. So this is the very important relation, potential due to disk. Now this is the important question from your book, that is the determine the potential at 004 meter caused by a total charge 10 to the power minus 8 distributed uniformly along a disk of radius 4 meter lying the z is equal to 0 plane and center at the origin. What does it means? We have to calculate the force. We have to calculate the potential at 004 caused by a charge. What is the value of the charge? Charge is given as 10 to the power minus 8 coulomb distributed uniformly along the disk of radius of 4 meter. So what is the value? This is the 4 meter and z is equal to 0 plane, only xy plane, and center of at the origin. So here we can calculate a is equal to x. A is equal to x, and what is the value of x? X equals to a is equal to given as 4 meter. So first step, we have to calculate dB. What is dB? Already we have known that the dB is equal to rho s root of a square plus h square minus h. What is step 2? We have to calculate charge per area. What is charge here given? Charge is given here as the Q. And what is the cross-sectional area? This is a circle. So charge is Q. What is the rho is then? This is a circle. So this is pi r square. What is the surface area? This is pi r square. And what is how to calculate the pi r square value? Here it is given. Sorry, this is given as 5 meter. You've taken 5 meter. Okay, so if it is 5 meter, it will be pi 25. Actually, this is our r. R is given as 5 meter. So it is given as pi 25. This point is also then 5. Just a little change in the problem. Whatever. So what is rho s? Rho s is nothing but the 10 to the power minus 8 total charge divided by pi r square, means pi 25. So what will be the value of dB? dB by 2 epsilon, rho s by 2 epsilon, rho s we have already calculated, 2 epsilon root of 5 square. What is 5 square? A is the radius. It is given as 5. And what is the potential? We have to calculate at 0, 0, 5. So this height is also 5. So height is also 5. So 5 square plus 5 square minus 5. And the value is coming as 14.9 volt. So what is the main step? First step is we know that dB. dB is equal to root of a square plus h square minus h. Then we have to calculate the charge. Charge is equal to Q by area S. So Q is equal to 10 to the power minus 8. What is rho S? Rho S is equal to 10 to the power minus 8 divided by pi r square. R is equal to, it is given as 5 meters. So 10 to the power minus 8 pi by 25. Now what is dB? dB is nothing but we are putting the value. It is given as A. A is 5, the radius. What is height? It is given 0, 0, 4. So it is 4 square minus. What is the next one? Next one is the h. H is the again height. H is the height and it is again given as the 5. So we are putting the value and we got the dB is equal to 14.9 volt. If we take the previous question, if the radius is 4 meter, if we give second case, case 2. If we take radius is equal to 4 meter, what will happen? The rho s will change as the 10 to the power minus 8 divided by pi into 4 square. 4 square means 16. And what will be the value of dB then? The dB value will be changed as the, what will be the value of dB then? Rho s by 2 epsilon root of 4 square plus, if it is also 4, plus 4 square minus 4. So this is only the change if it is given radius is equal to 4 meter and height is equals to 4 meter. So this is the another case, same problem with the another value. Next, this is the third important problem of this topic. Planes x is equal to 2 and y is equal to minus 3 respectively carry charges 10 nanocoulomb meter square and 15 nanocoulomb meter square. So there is two charges you can see. This is our x, y, z axis and you can see this is our x axis and x equals to 2. There is a surface. Similarly, y is equal to minus 3. this is another surface is given. Next, and what is the value of the charge? The charge at this point is given as the 10 nanocoulomb per meter square, and for this it is given as 15 nanocoulomb per meter square. Again, if a line x equals to 0 to z is equal to 2, there is a line also, this is the line x is equal to 0 to z is equal to 2, carries a charge of 10 pi nanocoulomb per meter. The line charge density is given as the 10 pi nanocoulomb per meter. Calculate the field intensity for the 3 charges, 1 charge, 2 charge and 3 charge. Of the 3 charge. What is the value? Calculate E at 111. So, what is E? We know that the total intensity is E1. What is E1? E1 is the charge due to sheet 1. What is E1? E1 is the charge due to sheet 1. Next, E1 plus E2. What is E2? The intensity due to sheet 2. Second sheet, E2 due to sheet 2. Plus E3 due to the line. E3 due to the line. So, we have to calculate it one by one. So, what is E1? We know for the surface charge density, already we have discussed that for the surface charge density, intensity E1 is equal to rho s by 2 epsilon 0, and the direction we are taking as minus ax because it is in the minus side. Now, what is the value of rho s? Rho s is given as 10 nanocoulomb per meter square. 10 nanocoulomb. 10 into 10 to the power minus 9 to epsilon 0. That you can use the formula also. You have just put the formula of epsilon 0. 1 by 854 into 10 to the power minus 12. That value only we have put. What is E2? E2 is, as this is, so what is the value of E1 we are getting? We are getting the value 180 pi into AX. We are getting the value of E1 is equal to minus 180 pi by AX. Now you can see the EY2. Y2 surface is in the minus 3. So the direction will be in the positive side. So that's why we have taken at rho s 2 epsilon 0 AY. We have taken it as the AY. Direction will be always in the right hand side rule. So it is plus AY. So what is the value we are getting? It is given 15 nanocoulomb per meter square. 15 nanocoulomb per meter square by 2 into 10. Similarly, you can put also, if you want, you can also put epsilon 0 is equal to, if you want, you can also put the value epsilon 0 is equal to 8.854 into 10 to the power minus 10. You can put 8.854 into 10 to the power minus 12. This value also gives the same result. So, what is this? 2 epsilon 0. So, if after solving we got E1 is this, E2 is equal to 270 pi AY. Now, we are coming to the third session. It is for the line. So, we have to take the line charge density. And what is the line charge density is given? The line charge density is given in this problem is the 10 pi nanocoulomb per meter. What is the meaning of line charge? Line charge is nothing but the charge per unit length. So, what is the length? We have to calculate the distance. We have to calculate the distance. And what is the formula? As this is the line charge density, we will assume that this is in a cylinder. When we are thinking about the overhead line, the shape of the overhead line is always a cylindrical in nature. The overhead line is always cylindrical in nature. So what is the length? length is given as 1, 1, minus 1. Why this point is like this radius? Because we have to calculate the intensity. If we go in the previous slide, we have to calculate the intensity as 1, 1, minus 1 point. So from the line, we have to calculate the intensity at 1, 1, minus 1 point. So the point is, end point is 1, 1, minus 1. And what is the another point? It is given as the, from we are taking x is equal to 0, the height is z is equal to 2. The point is given as this line. And what is the point of this line? You can see the total line equation is x equals to 0, z is equal to 2. So z is equal to 2, x is equal to 0. But if we connect these two lines, it will meet at the y is equal to 1. So that's why y value is equals to 1. I will tell it once again. The point we have to calculate the intensity is at 1, 1, minus 1. This is the end point. What is the starting point? This is the starting point, this line. And we have to draw the perpendicular from this point to the line. This is the perpendicular we have drawn. When we are drawing the perpendicular, this line equation is x equals to 0 and z is equal to 2. And y, it is cutting the y at, as this is the perpendicular value, it is cutting the y is at 1. So this is the r value, and if we take the end point minus starting point, we are getting 1, 1, 0, minus 3. And if we write it in the vector form, it is coming as ax minus 3az. So what is the radius? Radius is root of 1 square plus 3 square. So it is square root of 10. Now, what will be the value of E3? Then E3 is equal to, what is the formula? Rho L by 2 pi epsilon 0 into rho. What is rho? Rho is nothing but the radius of the cylinder. It is nothing but the radius of the cylinder. So what is the value of rho? Rho value is square root of 10 is equal to 3.16. What is the value of rho L? The line charge density, it is given in the previous slide. The line charge density is given as 10 pi nanocoulomb. 10 pi nanocoulomb means 10 pi into 10 to the power minus 9. 2 pi epsilon value we know into square root of 10 means 3.16. And what is the direction? Direction is always given as the arrow. The direction of intensity is always in the radially. The intensity direction is always is the radially. So we put the value and we got E3 is equal to 18 pi ax minus 3az. So what is E? As I defined earlier, E is equal to E1 we got plus E2 we got and plus E3. So what is the step? The first step, we have to calculate the intensity. So what is the thing? We have to calculate the intensity 1 by 1. Then what is the next step? We have to calculate it for the each surface. We have to calculate it for the each surface. Surface 1 for x is equal to 2. Surface 2 for y is equal to minus 3. And the direction of the intensity is always negative to, always opposite to the surface. As it is in the positive x direction, the intensity is always in the negative ax direction. This is the one catch point. This is the one catch point. What is the, as y is in the negative, then ay should be in the opposite side. Then we have to calculate for the line charge density. Problem 4. Determine whether or not the following potential satisfies the Laplace equation V is equal to x square minus y square plus z square. So we have to check the Laplace theorem. What is the Laplace theorem? Laplace theorem tells that the grad square V equals to 0. It is given grad square V equals to 0. What is the meaning of grad? Grad is nothing but the del by del x plus del by del y plus del by del z. So if we want to calculate the grad square, what will be the value of grad square? In the xyz axis, del by del x square plus the second double derivative of del by del y square plus del by del z square. So this is the grad of any equation. Now we are calculating grad square V. Means V should be double integrate with respect to del square V del square x plus del square V del y square plus del square V del z square. If it is equals to 0, we can tell this is it will prove the Laplace theorem. So let's check what is V is given as. V is given as x square minus y square plus z square. So if we calculate grad square V, x square plus y square plus z square by grad x square plus grad square y minus y square plus this is with respect to z. What will be the integration? First integration, as this is with respect to z, x term and z term will be 0. So we will get it 2x. Similarly, so what will be the integration? What will be the next line? Del by del x 2x minus del by del x del y 2y. Similarly, here we are getting only z term plus del by del y 2z. 2 minus 2 plus 2 is equals to 2. As the result is 2, is this satisfies the grad square dot v? No, because if grad square dot v equals to 0, then only we can prove the Laplace theorem. So we are getting the value is equals to 2. So already we got that grad square v for this equation, for the equation 1, grad square v is equal to 2. So we can tell grad square v is not equal to 0. We can tell grad square v is not equals to 0. So it will not satisfy the Laplace theorem. Laplace equation is not satisfied. So we can tell it will not accept the Laplacian theorem. Next question B. What is in the question B? Question B is in r cos phi into z. So we can see this is in the r phi z. So which one is this? Is this the Cartesian coordinate? No. What coordinate is this? This is the cylindrical coordinate. This is given in the cylindrical coordinate. So how to calculate the cylindrical coordinate? What is the formula? The formula is 1 by r del by del r, when we are doing it with respect to r del v by del r. What is the formula of grad square? grad square formula is given as 1 by r del by del r into r del v by del r plus 1 by r square del square v del phi square. So it is with respect to phi. And what is this? Del square by del z square into v. So we have to differentiate three different things. First one, we will start from this. So in the v equation, we got p is equal to r cos phi plus z. So what will be the del square v del z square? The first term, so we can write first one is the del v, sorry, del by del z r cos phi plus z. To differentiation. For the first term, there is no z term, so it is 0 and it is 1. So we can write del by del z is equal to 1. So what is the value we got? If we write the grad square v, for the first term, del by del z into 1 is equal to 0. So first this term is 0 for the after the double differentiation. Next we will differentiate the next term. Okay, what is the next term? 1 by r square del phi square r cos phi plus z. So we can see here z is constant, so z we can remove. So 1 by r square, r is not the variable, 1 by r square into r del square by del phi square of cos phi. So first differentiation of cos phi is equals to minus sin phi. Second differentiation of minus sin phi is again cos phi. So we got minus 1 by r sin phi. How? First del by del phi is of cos phi is equal to minus 1. For the second time, when we are differentiating it, we are getting the opposite. So first cos phi to sin phi, again sin phi to cos phi. So first time we are getting minus sin phi. Next time we are getting minus 1 by r cos phi. So we got the two equation. Now we have to integrate this one. 2 times. First r d del v del r. So let's do the last one or first one. We can write that till. So how to do this one? V is equal to given as r cos phi plus z. Next we are doing this r del v del r. Okay, we calculate the del v del r first. So here z is constant, it is 0. R cos phi means only we are getting the cos phi. R cos phi del v del r. So cos phi is constant, del r into del I is equal to cos phi. Now we calculate the del v by del r. We are calculating the value r del v del r. We are calculating this value. So again we are getting r cos phi. Again differentiation of again we are calculating the del by del r of r cos phi. And we are getting the integration. What is the integration we will get? The integration we will get as, if we calculate again, 1 by r del by del r of r cos phi. Again r and r will be 1. So 1 by r cos phi. So we got the integration 1 by r cos phi here. So if we put the value grad square v is equal to for this 1 by r cos phi. For the second integration we got minus 1 by r cos phi, and third integration we got 0. So overall grad square v, overall grad square v equals to 0 and Laplace equation is satisfied. Laplace equation is satisfied. So these are the one important problem. What are the steps? First we will start with the last one, r cos phi plus z. What is the double differentiation of r cos phi plus z? Cos phi don't have any r cos phi don't have any z term, so del z is equal to 1, and second differentiation it is 0. Then we will calculate the del square v by del phi square. We get the value minus 1 by r cos phi. Then we will differentiate this one. So this is the, as it is grad square v equals to 0, we can tell the Laplace equation has been satisfied. So this is the today's topic we have discussed. First one, just a quick revision. First one, we have discussed the potential work done in a electric field. Then we calculate the one problem. Second important thing is the what is potential and what is the potential in a disk. Then we solve a problem on the disk. Next, on the third question is a intensity for surface plus the line. It is a mixed case of the line intensity and surface intensity. And last one is the Laplace one. So we have discussed these questions, and today that's our today's class, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.